Math. And today we're going to dive into percentage. And so just as a quick review between fractions and decimals, I'm going to give you a couple of questions and then let's just do a review and then we'll move into percent proportion. Okay, so I'm going to take you down to my desk and write down a couple problems. The first one is, what is 2/9 written as a decimal and also written as a percent? Okay, 2/9 is a fraction. I would like to know, what is that as a decimal and what is it as a percent? Okay. And then if you finish that one, let's look at 6/11. That's the second one. Okay. Okay, so you can use a calculator if you'd like. I'm going to do this first one longhand just in case it's been a fat minute since you've done this. So you rip off the numerator, throw it in the box. The denominator goes outside. 9 does not go into 2, so we put a 0 there. And we drop a 0. 9 does go into 20 twice. 2 times 18. Okay. And that's another 20. And this decimal point gets pushed up. Okay, and so this is going to continue with the 20 minus 18 and so forth. Okay, so it's going to be 2, 2, 2, 2, 2, 2, 2. So 2/9 is equal to 0.2 bar. It's also equal to, multiply this number by 100, move the decimal point over. We call that 22.2%. Okay, is how we would write that. Okay. 6/11, same way. The 6 is going to go in the box. The 11 goes outside the box. And let me scratch out the 18 so it doesn't interfere with what we're doing. All right, so 11 doesn't go into 6, but it goes into 60 5 times. Okay, make sure you push up your decimal point. Okay, 5 times 11 is 55. And you're left with a 5. You're going to drop it down. 11 goes into 50 4 times. So we're going to minus 44, and now we get a 6. You can drop another one, and you can keep going. Okay, but I'm going to stop here. And so 6/11 is 0.54. It's also 54%. Now, if you want to see what the next one is to know if you should round this up or down, you can absolutely do that, and we're actually going to round up. So this would be 54.5%. If you take it to another decimal point. Okay, good so far? Hopefully that's review, right? This is not anything new. Okay, let's also review our translation problems where we talked about what is a certain percent of a number. So translating this into math, a math equation. Okay, so translating words into a math equation. Okay, so what do you get for this one? Yeah, you can use a calculator, that's fine. Okay, I want to see what you write down though for translating it. Do that first. What is, I'm going to write this as a decimal, of 35. Okay, so of is multiply, is equals, what is the thing we don't know? Okay, and so grab your calculator. I'll slide this over. We have 0.12 times 35. Okay. Did you get 4.2? Good. It's not percent. It's not percent. Okay. So if I had $35 and I spent 12%, I would have $4.20 left. Okay, because the what is of this number. So whatever the units are here, same units here. Okay. Okay, what if I gave you one that looks a little different? What if I said 50% of a number is 12? What's the original number? Can you just do this one in your head? 50% of a number is 12. So 50% is 1/2 of a number is 12. It's kind of stretched out there, isn't it? So 1/2 x is 12. So some number divided in half gives you 12. I can multiply both sides by the reciprocal of whatever's in front, if you just want a straight calculation. How did that look? Okay, now can you tell me what is 150% of this number? Okay. Yeah, there's no handout for today, but I will show you where the handout is on the website at the end of class if you'd like. Okay. So how would you figure out what is 150%? Okay, I'll give you about 15, 20 seconds, then you tell me. Okay. So let me rewrite that. What is 150% of 24? Okay. So what, oops, is the equal sign. 150%. So you can write that as a fraction. Just take whatever's in front of the symbol and put it over 100. Of is multiply and 24. Okay, and then all you need to do is crank that into a calculator. So this is going to be 1.5 times 24, which is 36. All right, so how are you feeling about that? Are you feeling pretty good? Like that's a review? Okay, good. I would like to throw a party. Would you come if I threw a party? Okay, so I know we've done some party planning in our assignments, so let's do one together. And so I actually had a party. We invited 200 kids, not to my house. It was to a park. 200 kids. All right, so you're going to help me do some party planning. Here we go. So 200 kids were invited. Would you imagine how crazy it would be if they were in your house? That'd be nuts, right? Okay. How many do you think came? Or how many said yes? RSVP. That means they said, we'll be there. We had 146 say, yep, we'll be there. All right. So for something like this, you need to do some calculations to make sure you don't run out of food, that you have enough for everything, right? So you can't just, if it's just like 2 kids coming over, you can wing it with what's in the fridge. But with this, you have to do some kind of planning. Okay, so I want to know what percent are coming. That's a COMING. What percent are coming? Can you tell me? Would you come to mine if I hosted it? Sure. By the way, we invited people from the community one time, and I invited, I just said it was available. I said, whoever wants to come to the airport, and here's your quick story. Whoever wants to come to the airport and get a 20-minute ride in an airplane. I had like 10 or 15 pilots lined up who wanted to do this because we wanted to inspire kids to become pilots. Guess how many people showed up? I just had this little flyer, and I'm like, hey, it's like $9. That way, it's something, right? So people, if it's free, then people don't want it. So I'm like, okay, it's $9. 500 people showed up. I got in so much trouble that day. 500 people showed up for a flight, and we had 15 planes running nonstop all day. That was crazy. So now I know to ask for RSVPs and have tickets. Yes, I learned a good lesson that day. Okay, so what percent are coming? Did you get me a number? Was I too distracting by telling you a short story? Okay, come on, you can do it. What percent are coming? Okay, what's the whole? Okay, so 100% is 200. Good. All right. And I want to know, out of 200, 146 are coming. What is that That's my x. Okay, so we're going to multiply this way. I get 146 times 100. Okay, and then I'm going to multiply this way. Equals 200 times x. Divide by whatever in front of the x. Get rid of it. Make sure you do it to both sides of the equation. Okay, and what do you get? I get 146. You make sure you're doing the calculation with me to make sure you are getting the same answer I'm getting. Okay, so x is 73. Now, is that a percent or is that a number of kids coming? That's right, that's a percent. 73%. Okay. Now, do you think when I'm doing my party planning, I should plan on 73% capacity? Or do you think people are going to show up and bring their friends? Yeah, that happens, right? Okay. And sometimes people don't show up, right? So sometimes it works out. In my experience, I usually find a 10% buffer keeps disaster from happening, like running out of food. So how many kids am I expecting if I add 10% more? Okay. So 10% of, well, I guess you could do it either way. Let's add it 10% more. Can you do that in your head? What's 10% of 200? Yes, 20 kids. So instead of 146, I'm going to say, let's plan on 20 more. So that's 166 kids showing up. Okay, so I'm going to plan and do my buying for sodas and event stuff based on that number. Good. All right. That's it for the planning. Now let's do a different problem. You like that idea? Oh, what kind of party was it? Of course it was a science party. Of course. Okay, good. All right. Here's some real statistics. 38% of working adults, so adults that have jobs, working adults, do not like math. Okay. 23% of working adults do like math. It's like, wait, where's the rest of them? Yeah, they were kind of neutral. All right. So in the UK, the United Kingdom, they have 33 million people, adults, working. I should say adults to keep the language the same. 33 million adult people. Okay, you know what I mean. Okay. So how many actual people like math? Which numbers would you use? Yes, these are real numbers. So what numbers would you use?